Okay, so let's talk about some other trends or other ways we can determine the strength of acids or bases. So there is a periodic trend, generally speaking, that as we go across a row or down a group, the acid strength increases, which would mean that the base strength decreases, right? Because remember, they are inversely related. Now, if we look at the molecular structure, essentially the atom, so we have here a general structure of an element. If it basically has this form, we have some element that is bonded to a hydroxyl group, this oxygen and hydrogen, and then some other groups here. So if we have this general structure, these compounds could be acidic, basic, or amphiprotic, depending on the electronegativity of element E. Essentially, you're comparing the electronegativity of element E and oxygen to determine, right, if this bond will break or if this bond between oxygen and hydrogen will break. So if we have a lower electronegativity, then the bond between the element E and oxygen will be polar or ionic. And so that means, right, that this bond can easily be broken. And so we would release OH or hydroxide ions into the solution, thereby making this compound basic, right? Examples of such compounds are where we have transition metals as element E because they typically are lower in electronegativity compared to oxygen. Now, if the electronegativity of element E is high, then this bond between element E and oxygen will be covalent, right? And a covalent bond is pretty strong, so it won't break. Instead, bond B will break and we would release H pluses into solution, right? So the electron density will be pulled from bond B, releasing H pluses into solution, thereby making the compound acidic. Examples of such compounds are nonmetals. Nonmetals tend to be higher in electronegativity, and so they would be acidic. Now, what if the electronegativity of element E is intermediate, right? It's not super high or low, it's like in the middle, which is usually the case for metalloids. This is an example of where the molecule is amphiprotic, meaning that it might, in the presence of a strong acid, the compound will release hydroxyl groups, and in the presence of a strong base, it'll release H pluses, right? So it basically can release both hydroxyl groups or H plus ions, just depending on if it is in a strong acid or a strong base. And as I mentioned, examples of this are the metalloids or elements that are near them. An example is aluminum.